Alright, welcome to the lunchtime video. Really productive weekend. I didn't accomplish all of my goals, unfortunately, but I didn't, they were stretch goals, so I didn't have to accomplish all of them. What I did accomplish, though, is the entire VPNs. Um, so, oh, sorry, no. That's what my stretch goal was to accomplish all of this. But I did make it through L2VPNs. We did 3 different scenarios. One where you just connect L2 circuits. I did 3 scenarios. One where you connect an L2 circuit to another L2 circuit. One where you connect an L2 circuit to an L3 VPN, and one where you connect an L circuit to an L2 VPN. So I think I am having a problem where I can't get the IW interfaces for some reason. So I tried it with a logical tunnel interface instead, but it still didn't work. And not only that, my L2 VPN configuration wouldn't work either. So I'm hoping in this next topic, of which I'm gonna finish today, I'll do a after work video and finish this whole topic today. I have to keep that pace. I'm thinking I'll be able to figure out where I went wrong in the last one and come to a better solution. So yeah, let's put this like that, perfect, and then this is L2VPN. L2VPN. Perfect. Okay, and then yeah, space that out, and then we need the tags. Okay, we've got the tags. Okay, so that looks good to me. Next step is going to be, we'll just go with the help apropos as normal. Unfortunately, the help apropos really hasn't, in my opinion, been fruitful a lot of the time. I'm kind of left high and dry most of the time I use it, but I think it's gonna be okay. So the thing is, I already have an L2VPN, so let's do the help apropos. What I'd like to do is just get rid of the IW interface, the interconnection, and just strip it down to its basics, make it really easy. So basically I'd like to expand this out so that this site is a part of the LVPN just like the other sites. Sorry, the L2 VPN. The L3 VPNs, I've got a pretty good handle on. Okay, so let's use help apropos. So I'm really confused about whether my core interfaces need an IP address or not. Let's start there actually. So we're gonna say Juniper L2 VPN core interface IP. Okay, so they do have core IPs. In fact, this looks like it might be what I want. Yeah, this is it exactly. Okay, so let's add this to the notes. Yeah, this is the information guide too. This is it. This is exactly what I need. Okay, but let's see what we've got in help apropos, just because that's what I'm gonna have during the test. Okay, looks good to me. Got lots of good help here for L2 VPNs. Yeah, Yeah, we've got good examples here. Let's look at the configuration. Yeah. Okay, I want this remote site ID. So configuring the remote site ID, this is something I was confused about before, so it looks like we got some good documentation for that. Let's just read it. The remote site ID allows you to configure a sparse layer 2 VPN topology. A sparse topology means that each site does not have to connect to all the other sites in the VPN. Thus, it is unnecessary to allocate circuits for all remote sites. Remote site IDs are particularly important if you configure a topology more complicated than full mesh, such as a hub and spoke topology. The remote site ID configured with the remote site ID statement corresponds to the site ID configured with the site identifier statement configured at a separate site. I think this is where I went wrong. Relationship between the site identifier and the remote site ID illustrates the relationship between the site identifier and the remote site ID. Okay, so I think I still have the configuration actually, so I can probably just fix this and see it come up. So yeah, so I can probably set up a remote site ID here. I think. I'm not sure why this isn't what I'm expecting. Oh, I see, because I need to go under the interface. Yeah, like that, and then now I can do remote site ID, but it's going to be interface 1, not interface 0. Okay, so we'll need to do the same thing over here. Perfect. Okay, so that's obviously not the answer. Why is there a bunch of extra stuff? Okay, there's extra stuff in this because I've got trace options configured. We've got everything looking good. Yeah, everything looks good to me. Now I'm surprised that this would be the core interface. Let's try making that the customer interface and see if that changes anything. Oh, and you know what? Yeah, so this is the iteration where we have the yeah, the IP address is taken out. So let's roll that back so that the IP addresses are in there. Okay, and I might need to do that for some other ones as well. Yeah, okay, well, oh, okay, so now let's go ahead and okay, so now let's go ahead and see if this works. So we've got a number of things. Oh, I think it's talking. Oh, this is interesting. It switched from LD to OR. So LD local site. So out of range. That's interesting. Okay, but we do have the. Okay, we don't have the remote site anymore, and now we have the customer interface in there. That's interesting. Here we're just missing the interface altogether. So let's start with that. Oh, it looks like they're... Oh, I see. No, this is the name of the protocol. That other thing is the name of the routing instance. There we go. Okay, let's see if that triggers any messages on this side. Okay, I don't see anything yet, so let's add the remote to both sides. Okay, so we still got problems with our L2 circuit. It's in state OR. Okay, so let's follow along closely with this documentation here. So it's going to start. Yeah, so they're going to give us everything, Cs, Ps, the whole shebang, which is excellent. So we've got a limited amount of time, but let's do the reading. So MPLS-based VPNs require baseline MPLS functionality in the provider network, which includes IPs on the core links. Yeah, so MPLS requires IPs on the core links. So there's my answer right there. The core links do absolutely require IPs because we need baseline MPLS functionality. And then provider routers require only a baseline MPLS configuration because they are not VPN aware. VPN state is maintained only on the PE device. This is a key reason why MPLS-based VPNs are so scalable, because you never know how many P routers you're going to have. So to go and update 100 P routers is not very scalable. So this example focuses how to add L2VPN to a pre-existing MPLS baseline. A basic MPLS configuration is provided in case your network does not already have MPLS deployed. To support MPLS-based VPNs, the underlying MPLS baseline must provide the following functionality: core-facing and loopback addresses, operational with MPLS family support, an interior gateway protocol such as OSPF or RSVP to provide reachability between the loopback addresses of the provider P and PE devices, an MPLS signaling protocol such as LDP or RSVP to signal LSPs, LSPs established between PE device loopback addresses. Okay, so they're spelling it out here perfect for me, so I'm definitely going to include that in my notes because that's exactly the thing I was wondering about. LSPs are needed between each pair of PE devices that participate in a given VPN. It's a good idea to build LSPs between all PE devices to accommodate future VPN growth. You configure LSPs at the edit protocols. Yeah. Unlike an MPLS configuration for cross-connect circuit (CCC), you do not need to manually associate the LSP with the PE's device's router customer-facing edge interface. Instead, Layer 2 VPNs use BGP signaling to convey Layer 2 site reachability. This VPN signaling automates the mapping of remote Layer 2 VPN sites to LSP forwarding next hops. This means that with Layer 2 VPN, explicit mapping of an LSP to a PE device's edge-facing interface is not required. A Layer 2 VPN provides complete separation between the provider and customer networks. The benefits of a Layer 2 VPN include support for non-standard transport protocols and the isolation of link addressing and routing protocol operation between the customer and provider networks. Definition of VPN involves changes to the local and remote PE devices only. No additional configuration is needed on the provider devices aside from baseline MPLS support. Because these devices only provide basic MPLS switching functions, the CE devices do not use MPLS. They require only a basic interface and, if desired, protocol configuration to operate over the L2VPN. For a Layer 2 VPN, you configure the CE devices as if they were attached to a shared link. Yeah, so L2VPN is basically just a shared link. L3VPN, not exactly. Once an MPLS baseline is in place, you must configure the following functionality on the PE devices to establish an MPLS-based Layer 2 VPN, a BGP group with family L2VPN signaling, a routing with instance type L2VPN, The customer-facing interfaces on the PE devices must be configured as follows. Specify Ethernet CCC or VLAN CCC, physical layer encapsulation depending on whether VLAN tagging is in use. Configure a matching encapsulation type in the routing instance configuration. Configure the logical interface unit used for the Layer 2 VPN with family CCC. Figure 1 provides the topology for this MPLS-based Layer 2 VPN example. The figure details the interface names, IP addressing, and protocols used in the provider network. It also highlights the end-to-end nature of the CE device addressing and protocol stack operation. Unlike a Layer 3 VPN, CE device operation is opaque to the provider network in a Layer 2 VPN. There is no peering relationship between the CE devices and the provider network. As a result, you expect the CE devices to form an OSPF adjacency across, not to, the provider network. Quick configurations. Use the configurations in this section to quickly get your MPLS-based Layer 2 VPN up and running. The configurations include a functional MPLS baseline to support your Layer 2 VPN. This example focuses on the VPN aspects of the configuration. Refer to the following links for additional information on baseline MPLS functionality. So baseline MPLS functionality, I think, is where I had been getting confused. I thought that the difference between a L2 and an L3 VPN and VPLS, for that matter, included differences in baseline MPLS functionality, but that is not at all true. They're going to be exactly the same. So really good to have that cleared up. This is the perfect documentation, so let's try to get as far as we can with it. If I don't finish the whole thing, that's okay. I will be able to finish it in the after work video. So note, the device configurations omit the management interface, static routes, system logging, system services, and user login information. These parts of the configuration vary by location and are not directly related to MPLS or VPN functionality. Edit the following commands as needed. Okay, so let's start with the PEs, and we're going to be straying a little bit from what they have here because we're going to be making it relevant to our own documentation. First things first, I'm going to go ahead and blank out all the configurations. Okay, so I'm not sure which routers got opened and which ones didn't. I know that I configured 4 of them. I think it was the... Yeah, I'm not sure. So we'll just go through and explicitly open up the console to all of them. Hopefully that will be an effective strategy. Usually it is not an effective strategy to do basically any strategy, but we will try. Doesn't hurt to try. Sometimes it hurts to try. And I do have a pretty bad stomachache right now, so I'm trying and I'm in a lot of pain. But it's not caused by the trying, as far as I know. It's caused by consuming too many calories. All right. Oops, something's going on. Oh, there we go. Yeah, I don't think I'll need tunnel services. We're not doing any stitching in, anything like that. Nothing fancy. This is just going to be the basic bread and butter of what's on the exam. And then any fancy things, I'm hoping maybe I can use help apropos to figure that out. But at this point, if I don't know a basic MPLS foundational config, I'm in a lot of trouble, but I do know it. You just got to configure the interfaces, then you got to configure signaling protocol, then you've got to configure IBGP, and then you need an LSP. Unless you're using LDP, then you'll have LSPs automatically. Okay, so everything looks good to me. Let's work on the CEs next. Okay, so the CEs, it looks like they're going to have, yeah, we're going to be pinging, oh, I see though. We have a topology like this. My topology is a bit different. I'm going to have an extra one. So a /30 isn't going to work for me. Let's go with a /29. And we'll use 1, 2, and 3, but we'll use OSPF and be able to ping the loopbacks when this is all over. Okay, and I might wanna. I'm gonna rename it to CE1. I'll keep the icon name the same though. You know what? I'm gonna go. Oh, actually, for this one, okay. So we'll use their. No, you know what? Let's use the onion addressing scheme that I came up with. So it's gonna be a little bit different because the layer of the onion. Oh, I see. The layer of the onion doesn't have different IPs, So of course we're going to have these links, which are going to be our regular. Oh, sorry. So yeah, so these links are basically all connected to each other. This is one broadcast domain. It's as if it's going into a hub. So we're still going to have our onion strategy, but it's going to be 10.0.1 for all of these because we just need a network. So .1, .1, .2, and .3. And this is for the this interface. Okay, so yeah, we can delete all of this. Okay, so let's think about what it's going to be. Okay, so it's going to be, so we've got that one. Oh, I see, yeah, so what I just said. 0 for the most outer layer of the onion, and 1 for the network that we're going to use. We're only going to use one network. Normally we would have .1, .2, and .3, but here we'll just need .1, and then this is going to be .1. We'll use a /29. Okay, and then we'll use our regular convention here. Okay. Looks good to me. Oops, that's a compare. Let's do a display set. Okay. And then, yeah. Okay, so now let's configure the other routers. Okay. Okay. Oops, so we've got a problem here. We cannot have the same local interface on the same unit. So we've got a /24 on there already. Let's get rid of that. I wonder if these were properly blanked out. I guess it doesn't matter now because everything looks good. Okay, so we finished the CEs. Next is going to be the PEs. Quite a bit more complicated. Alright, and we're going to need to change it. Okay, and we'll rename this just on the CLI PE1. Yep. Okay, that all looks good to me. Alright, we won't need the MTU. Just for our own purposes, we're going to use the onion addressing. So this is, yep, .1, and then this is the first one. So it's .1. It's going to be a /30. Okay, of course we need family MPLS. Onion addressing, so this is the .1 layer. There we go. Okay, looks good to me. Yep, remote site 2. So this is what I had before. I'm wondering if this will work. Oh, so maybe I was missing this encapsulation type Ethernet. Maybe that's why it wasn't working. Yeah, that might have been why it wasn't working, because I was missing the encapsulation type. I wish I could go back, but it's too late now. I guess I could do a rollback. Okay, and then the autonomous system. Yeah, we'll just use their same autonomous system, that's fine. Local address is going to need to be different. Okay, neighbor's going to need to be different. And then we've got 2 neighbors, they've only got 1. So our scaling, we've only got 3 sites, but once you start getting more sites, you got to start thinking about using route reflector. So just like that, we're going to need more than just that one. Okay, so, yep. Okay, we're good to go. So I'm gonna hand write just this first one in, just because I wanna really get it on my fingers. The next ones, though, I'll just doctor up and paste in. Typically, I do hand write the first one. I think it's important to get a handle, like, you know, hitting the space key like makes it autocomplete all weird and stuff. Being prepared for that on test day is really important. Okay, I'm going to add in trace options on this one. Okay, so hopefully this will paste in. We'll doctor up the other ones and paste them in a few lines at a time, in the interest of time. Aha, but we've got no errors here, so let's do that. Okay, so this is still going to belong to this layer. Oh, sorry, no, it's going to belong to the next layer, so .2.1. Yep, .2. Oh, I hate feeling this fat. I feel like super fat right now. I think I need another one of these. Yeah, I think I'm missing a line of config. I can just feel my arms like inflated with fat. It's like I'm eating like super healthy foods. Well, except for even when I order out, like it's not like that bad. It's like I'm just eating a lot of calories. Okay, so yep. Yeah, we're gonna use a weird route distinguisher. You know what? No, let's make the route distinguisher make sense. Perfect, we're good to go. So next is going to be .2. Okay, so, yep, route target must match. Local address is going to be different. We're going to need different neighbors, different LSPs. Okay, but everything else is the same. Let's take a look at the documentation in case there's anything. Nope. Documentation looks good, so let's apply it. Depravity. I don't know why I just said depravity. It's kind of how I feel spending so much time on this test. Let's go back. Yeah, there we go. Okay, perfect. But now is burnout is a thing. It's a serious thing. But I've literally I would hate to take the test and just think to myself, if I had just studied an extra 5 hours, I would pass this thing. So I'm going to do everything I can to make sure I don't have that thought on test day. Oh, it looks like I got the description wrong. I'll fix that. Okay, so now we've only got the P routers left, which are typically a lot easier. Let's just leave off the descriptions because I just want to make things easier on me. Yeah, let's just make things as simple as possible. So we're going to use the onion addressing, so it's going to be starting here. Yep, no, yeah, dot one, so dot 2 slash 3, 10.1 dot 2 dot 2 3 1 dot 3 dot 2 slash 3. Yeah, it doesn't really matter what link is to what because they're all configured the same. I mean, I guess the IP address is different, but I don't think descriptions are as important here. I mean, knowing rapidly which interface is customer facing, which is core facing is really important, but on a P router, they're all core facing, so it's not as important to have good descriptions, in my opinion, on a P router. On a PE router, yeah, you gotta have good descriptions, otherwise you're kind of shooting yourself in the foot, or at least wasting a bunch of time. There we go. Alright, R9 is the last one, and then we'll probably have to do the verification steps in the next video, but that'll be totally fine by me. Okay, so let's take care of the addressing. Okay, so we've got the .1 layer, and this is G1. Wait, I'm confused. Oh, I think I misconfigured this link. This is meant to be 10.2.1.1. Yeah. Okay, perfect. So that's meant to be .10.2.1.1. So this is meant to be 10.2.1.2. This is going to be 10.1.3.2. Okay, we're good to go. Yep, we're good. So yeah, I think that's going to be a good stopping point, because we've got everything configured now. So in the next video, it's going to be the verification steps. So let's try to, yeah, here we go, verification in the next video. So I'll have that so we can link directly to that, and I'll make my notes for that right now. Alright, so thanks for watching, and stay tuned for the next video where I do the verification steps and try to troubleshoot and resolve any problems that I find. Thanks for watching, and see you in the next one.